What does it really mean for an AI to think? Today, we're diving deep into best AI model right now. Determining the best artificial intelligence model is no longer a simple task of looking at a single leaderboard. In 2026, the model landscape is highly fragmented, with different models excelling at distinct operational tasks, latency windows, and cost constraints. An enterprise must evaluate models across a multidimensional matrix, balancing raw reasoning power against execution speed, token cost, safety guarantees, and licensing flexibility. This keynote outlines how to evaluate the current model market and choose the optimal engine. But here's where it gets interesting: the multipolar model landscape. We occupy a multipolar model landscape where no single provider dominates. OpenAI's GPT-5, Anthropic's Claude 3.5 Sonnet, and Google's Gemini 1.5 Pro compete at the frontier of reasoning and coding. Meanwhile, Meta's Llama 3 and other open source models challenge proprietary systems on cost and privacy. This multipolar reality means that the best model is context dependent. The ideal engine for writing code is not necessarily the best engine for processing video or running local database queries. So, what's the real problem? Let's talk about frontier capability vectors. Evaluating frontier models requires mapping their capabilities across three core vectors: reasoning, context, and multimodality. Anthropic's Claude leads in logical reasoning, multi-file code generation, and constitutional safety alignment. Google's Gemini dominates in context length, processing up to 2 million tokens of input natively. OpenAI's GPT-5 excels in raw agentic planning, multimodal generation, and real-time voice and video interaction. Enterprise buyers must align their specific use cases with these capability vectors. This raises a critical question: reasoning versus speed trade-offs. In production, there is a constant trade-off between reasoning capability and generation speed. Running complex, high-stakes tasks through large models like Claude Opus delivers high-quality outputs, but introduces latency that disrupts user experiences. Conversely, lightweight models like GPT-4o Mini or Gemini Flash respond in milliseconds but fail on complex reasoning. Successful architectures deploy model cascading, using fast, cheap models to filter requests and escalating complex queries to frontier reasoning engines. Now let's zoom in on context window scaling. The expansion of the context window has changed how developers build AI applications. With Gemini supporting millions of tokens, developers can feed entire directories of files directly into the prompt space, bypassing the need for complex retrieval augmented generation pipelines for small datasets. However, long context windows introduce latency and cost penalties. Developers must balance the simplicity of large context windows against the speed and cost benefits of targeted RAG systems. Here's something most people overlook: cost performance optimization. Cost optimization is critical when scaling AI applications to millions of users. Using premium models for simple tasks like data extraction or classification quickly leads to unsustainable token bills. Enterprises must calculate the cost-performance ratio, finding the cheapest model that achieves the minimum acceptable accuracy. This is achieved by fine-tuning open-source models on specific task datasets, delivering frontier-level performance at a fraction of the proprietary token cost. Think about this for a second: specialization versus generalization. The market is shifting from massive general-purpose models to networks of specialized models. Specialized models are trained on specific domains like medical terminology, financial compliance, or code compilation. These models perform better and faster within their domains than general-purpose giants. The future of enterprise AI lies in orchestrating these specialized models, using a general-purpose model as the router and coordinator of the network. And this is where things get complex: evaluation frameworks. To choose the best model, enterprises must move beyond generic benchmarks like MLU and build custom automated evaluation frameworks. A custom framework evaluates models against real, historical user queries and edge cases from the company's own production logs. By measuring specific metrics like factual correctness, compliance safety, API calling accuracy, and latency, companies can make objective, data-driven decisions when selecting or upgrading their model stack. But here's where it gets interesting: the local all-lock source challenge. Meta's Llama 3 and Mistral's open models have closed the gap with proprietary APIs. Running open source models locally or within a private cloud provides enterprises with complete data privacy, zero API rate limits, and the freedom to customize weights. While proprietary models still hold a slight edge in complex multi-step reasoning, open source models are now the default choice for high-volume tasks, data processing pipelines, and sensitive enterprise applications. So what's the real problem? Let's talk about Enterprise Decision Matrix. The Enterprise Decision Matrix balances four key criteria: capability, security, cost, and portability. If maximum reasoning and coding are required, Anthropic's Claude is selected. If native media analysis and massive context are needed, Google's Gemini is the choice. If real-time voice or general agentic planning is key, OpenAI's GPT-5 is deployed. If strict data compliance and cost control are paramount, a fine-tuned open-source model is hosted locally. This raises a critical question: production integration realities. Integrating models into production requires building an abstraction layer between the application code and the model API. This layer allows you to swap models, cascade requests, and handle failures without modifying the core system. If a proprietary API goes down or changes its pricing, the abstraction layer routes requests to a fallback model automatically. This ensures high availability, optimizes token costs, and prevents vendor lock-in. Now, let's zoom in on strategic recommendations. The strategic recommendation for 2026 is clear: adopt a multi-model hybrid architecture. Avoid locking your infrastructure into a single model provider. Implement an abstraction layer, build a custom evaluation framework, and use model routing to match each task to the most cost-effective model. By orchestrating a mix of Claude, Gemini, GPT, and open source models, you capture the strengths of each, optimize token spend, and build a highly resilient system.